10.4 is using Pascal's triangle, and we started it last time. We had taken a look at this setup of how Pascal's triangle looks. And when we left, I mentioned that there is a connection to this, from this to our combinations that we've been working with, right? So I'm going to draw another Pascal's triangle so that you can see where the connections are, but I'm not going to draw 9 rows. There starts row 0. I'm not going to draw all the rows because once we establish how the rows are being created, it will simply pull over into the rest of them and you'll see what that's doing. So taking a look then at the same kind of setup as we had before, we've got row here. So we're going to start with row number 0. And the top, instead of it just saying 1, is going to say 0, C0. So we're just going to write them all in first, and we'll talk about them again, okay? So on either side of this, we're going to do 1, C0 and 1, C1. That's row 1. On row 2, we're going to do 2, C0. In the middle is 2, C1, and on the right is 2, C2. On row 3, it's 3, C0, 3, C1, 3, C2, 3, C3. On row 4, we can do 4, C0, 4, C1, 4, C2, 4, C3, 4, C4. And I've got enough space with the way that this pans out to write one more row widthwise, so I'll do one more. 5, C0, 5, C1, 5, C2, 5, C3, 5, C4, and 5, C5. So jot those down. And we're going to take an arbitrary one here and show you, by example at least, that it does in fact give you the same value that the other triangle gave you in that location. And I'm just going to use 5C3, okay? There's nothing special about it, I just picked one. This isn't even on my notes, it's random. So 5C3, what we learned last time with combinations is that means 5 factorial goes on top. And then on bottom, we do both the 3, right? And we do the 5 minus 3. So how many are chosen? 3. How many are not chosen? 2. And it looks like that. So this is 5C3 that I'm writing down right now. So this is 5 times 4 times 3 times 3 factorial, sorry. And then on bottom, I have the 3 factorial, and then I have 2 times 1. And if I cancel things out appropriately, the 3 factorials reduce. The 2 reduces with the 4 to become a 2. And I end up with 5 times 2, which is 10. Okay, everybody good so far? That's the connection back to what we were doing in 10.3. So I'd like for you to take a look at where we are. We're on row 5, right? And we're in position 4. If you're counting from the left to the right, we're in position 4, correct? So let's flip back over here. If I go to row 5 and I go to position 4, 1, 2, 3, 4, I'm at the value of 10, okay? So every value that has this combination form can be found in the Pascal's triangle, okay? So while I did not write out row 8, if I wanted to find 8C3, I would go to row 8, position, close. It's actually position 4. So it's always 1 beyond the 1. So on row 8, so I don't count this 1 at the beginning, and I would do 1, 2, 3. So I'm technically in position 4. 8C3 is 56. Okay. And we can read it straight off of the triangle. So using that as our reference point. Now, when you get to your homework, do you have to do it that way? No, you can calculate 8C3 in the way that we've done it last time, every time if you want to. You do not have to use Pascal's triangle to do this. But if you have Pascal's triangle as a reference point, you certainly could at least confirm both options, make sure that they're the same. Or you could simply do it from Pascal's triangle to begin with. So let's take a look at how this works with a couple of examples. We've got 6C3. So let's write down what this tells us to do. What row am I on? I'm on row 6. And what position am I in? it's position 4. It's always one more, okay? So position 1, that very first position is always the number 1, and then we do 3 more after that. So this is going to be position 4 since it's C3. So we're going to go over here to row 6, and we're looking at position 4. So here's 1, 2, 3, 4, and our number is 20. Okay, what about 8C6? What row am I on? Row 8. What position am I in? It's in position 7. Okay, the position is always one bigger than the value it lists after the C. One more than that gives us our position. Okay, so let's go to row 8, position 7. Row 8's the bottom one. So I've got 1, 2, 3, 4, 5, 6. This one would be 7. It's 28. Okay, so that's just simple, like how I find it. How is it actually being used is the same way it's being used as the values that we had done back in section 10.3. So if we have a problem, so we're going to look at one, we're going to do a committee. Do you remember what I talked about the word committee? Committee always means that you're doing a combination, like as opposed to a permutation. Something else that's actually valuable that you should sort of make mental note of, or maybe even physical written down note of. If you're doing a question from section 10.4, it's going to be a combination, right? Because 10.4, Pascal's triangle, only applies to combinations. So the cool thing is, do you remember how the My Math Lab codes things at the top, right, on the problem number you're working with? It always tells you the chapter you're in. We're in chapter 10. The section you're in, this is section 4, and then it tells you some problem number that they've assigned to it, right? So if you see the coding on the problem at the top and it says 10.4 point something, you know that you're going to be doing a combination, okay? So utilize those kinds of things, right? These are just how you take, tests and quizzes and do homework, is that you should make use of those kinds of details. It's important detail. Okay, so we're doing a committee. Anytime you see committee, it is also going to be a combination. So we have 3 people. They're going to be selected from among 7 women, that's important, and 3 men. And we're going to find the number of ways of obtaining each result. Okay? So, what is the total number of people that we're selecting from? 10. Our total is 10 people. Okay? Total is 10 people. We have 7 of them are women, so that's important, and 3 are men. So we may need to make use of any of those 3 numbers, and we need to be careful that we're using them in the appropriate way. This one says we want exactly 3 women. Okay, so how many women, not total, but how many women are there to pick from? 7. And how many am I supposed to be choosing? 3. So this is 7C3. Thinking about it from a Pascal's triangle perspective, what row am I on? Row 7. What position am I in? 4. Okay, so I'd like for you to go back to Pascal's triangle over here. We need row 7, position 4. 35. Is it the first 35 or the second, just for reference? It's the first one. Okay, row 7, position 4 is 35. So this value is 35. There are 35 ways of selecting 3 women to be on this committee. Okay? How about exactly 3 men? There's 3 men to pick from. And how many am I choosing? 3. Now, you probably at this point know that if it's a combination and the number at the beginning and the end match, the answer is going to be 1. Okay, that's a true fact. So if you have 7C7, 8C8, 10C10, it's going to be the answer 1. But let's actually show that that works. Okay, so this should be row what? Row 3. What position? Position 4. Okay, so if I'm on row 3, position 4, I'm over here. Yep. And I get, in fact, the number 1. Okay? So far, so good? All right, let's try another couple. Two more. This one, same setup, right? Problems 5 and 6. It says exactly one woman. Okay, so I need how many women? One. But I still need to have a committee of, no, 3. It's a committee of 3. Okay, committee of 3. It says one woman, so by default then, what does that mean is going to fill up the rest of my committee? 2 guys, right? I need exactly one woman and I need 2 men. It doesn't say 2 men, but it's there. Like I have to still have 3 people. And these are the people I have to pick from, okay? So how do I get exactly one woman? Well, how many women are there? 7. So this is 7C1. And then I multiply that by how I get 2 men. So how many men are there? 2. And I'm choosing, whoa, hang on. 2 is how many I'm choosing. How many men are there? There's 3. And then I'm choosing 2. So I have 3C2. All right, so let's find each of these values. 7C1 means I'm in what row? Row 7. What position? Position 2. And 3C2 means I'm in what row? Row 3. What position? 3. All right, so I need to go to row 7, position 2. So what is row 7, position 2's value? It is 7. It's right here. And I need, so this one's 7. I need row 3, position 3. So if I go to row 3, position 3, what value am I at? 3. My circling and squaring in are getting a little messy. I hope you're following with yours. This is 3. So this one's a 3. So I'm going to take that 7C1 value, which is 7, and I'm going to take the 3C2 value, which is 3, and I'm going to multiply them. 7 times 3 would be 21. Okay, same idea for 6, but now it says exactly one man. So if I have exactly one man, by default, that means who else fills out my committee? 2 women. So I need 2 women. Notice it says exactly, so it's not like I could have one man or more than, right? Like it says exactly. That's the phrasing they're going to use here, so be prepared for that reality. So exactly one man. Well, how many men are there to pick from? 3. And how many am I choosing? 1. What about my women? How many are there to pick from? 7. And how many are choosing? 2. So we're going to find 3C1 and 7C2. 3C1, what row? Row 3. What position? Position 2. 7C2, row 7, position 3. Okay, is everybody getting where all those numbers that I keep asking you for are coming from? Because now's the time to ask if you're not. Okay, do you have a question, Jonathan?
Yeah, so whenever, like, 3C1, right, why are we going to position 2 and not position 1? Why do we just, like, add one more onto it?
Why do we add one more onto it? The first position, okay, so if you go back to look at this right here, when this says 3C0, the first position is the 0th position. So if I'm looking for 3C1, it's actually in the second location. That's why. Yep. Okay, what were my values? I had 3C1. So row 3, position 2 is 3. So this one's 3. And then row 7, position 3. So row 7, position 3 is what? Is that one 21? Yeah. So row 7, position 3 was 21. And so back up here, I would multiply those values together. So 3C1 is 3. 7C2 is 21. 3 times 21 is 63. Okay. Now, if you absolutely hate Pascal's triangle and you don't want to use it for this, could you find 7C1 in a different way? Of course. Could you find 3C2 in a different way? Of course. So you don't have to use Pascal's triangle, but if it's connecting with the way you think about patterns and so forth and it makes sense to you, it cuts down some time. It's a very nice and friendly connection point, and you're welcome to use it.